To understand volatile keyword in Java, let's take this very simple example. Let's say that we have a main thread, and in the main thread, so what we do is we are starting another thread, let's call it T, and in our thread we are setting the while the running is equals to true. It's a global variable here, and while it's true, then we are just waiting, right? And after running is set to false, only after that we quit this while loop, and we are printing that it stopped, right? So we are printing that this thread has stopped. So the next one is in our main thread, we are starting our thread T, and we are waiting for 1 second. And only after that we are setting this value to false. Let's run it and let's see what's gonna happen, right? Let's run it and let's see what's gonna happen. What happens is, as you can see here, this thread, this program, right, which has the 2 threads, it's run indefinitely. It never stops. Let's wait a bit more and make sure that it doesn't stop. So it doesn't stop. Let's stop it. So why it happens, right? Why it happens? Why that this thread, we set this value to false. We expect that, since it's a global variable, we expect that thread T also will see that value and will stop while loop and will exit and will print it stopped. This happens is, let's look at the architecture. So what happens is that on the CPU and the RAM level, right? Let's visualize that. So let's say that in our RAM memory, right, we are creating one variable, running is equals to true, and we are starting 2 threads. So let's say we have a CPU with only 2 cores, and in the first core, so what we do is in the core 2, we are main thread is running, and we are updating value to false, and we are updating our CPU cache, and we are also updating in the RAM, right? We are updating that to false. But for another thread, for the thread T may not see that value, because thread T takes the value. Thread T, when it starts, it takes the value from the RAM and it caches in the CPU. So when the thread 2 changes that value, thread 1, right? Thread T may not see that value. So for that visibility, so for making sure that when we are changing a variable and the variable is changed in the RAM, to make sure that the visibility is the same for all, meaning that the thread 1, thread T, right here, thread T will also see that, we are adding a volatile keyword. So let's add here volatile keyword, and after adding volatile keyword, let's run it one more time. Now, as you can see here, it stopped, right? So that's why I put the comment here that without volatile thread may never stop. So meaning that these 2 threads may not see each other changes unless we are adding here volatile. Again, let's revisit that. So what we have here, right? So we are in the main thread, we are changing the value, and we want to make sure that that change is visible to other threads. So in what it does is, what the volatile does is, volatile writes back that value to the RAM, and it also makes sure that every other thread that is running sees that the latest value. But volatile only enforces the visibility. It doesn't enforce the atomicity. So atomicity we have seen earlier. So let's say that we have here not Boolean, but we have here int. Let's say that the count, right? We have here count, and the count is equals to 0. And if we are incrementing this value count, right? If we are incrementing that in the thread, that operation is done. So let's say that here we are incrementing that, right? So we are incrementing here, I'm busy watching. So let's say that, busy wait, and let's increment the count. Let's increment the count here, and we are incrementing the count. Let's make it static here. Static. So we are incrementing a count. This operation still will be done in 3 steps, right? I have explained that already in the synchronized episode. So this operation, we are loading that from the RAM, we are incrementing that in the CPU register, and we're writing that back. So this operation is still done in the 3 steps. And for it to be atomic, we still need to use the synchronized keyword. Again, volatile only makes sure that the visibility, only makes sure that the latest changes, as we have here, right? The latest changes is visible to all threads, but it doesn't guarantee the atomicity. For atomicity, still we need to have the synchronized keyword, which you can see in previous episode.